Hello everyone. So we got a problem over here that we wanted to solve, and let's read it out. It says write a program to print all prime numbers less than or equal to 1000. Print your result on a single line and use the ampersand character as your separator instead of a space. And here we have an example. For example, the output for all prime numbers that are less than or equal to 10 would be 2 and 3 and 5 and 7. Okay, so what they essentially want us to do is find all the prime numbers which are lesser than 1000 and concatenate them in the form of the prime number and then an ampersand sign and then the next prime number and so on and so forth, like it is listed out in this example. So let's try doing this with Python. I'll go to new cell. So first let's list out all the 1000 numbers that we are looking for, and we'll use the range function for this. If we did range 1001, then we would be including all the numbers between 0 and 1001, so we get the range object. But since we are aware that 0 and 1 are not prime numbers that we want to consider, so instead of 1001 we can say we want it's to start from 2 and go all the way up to 1000. So we'll have this range, and if we just want to take a look at it, we can list it out by using the list function, and here we have all the numbers between 2 and 1000, the last number being 1000. So let's go back up and remove this list. Let's iterate for I in this range, and then now we need to evaluate each number. The first number coming in through this iteration would be 2, and we need to evaluate if it is a prime or not. So how do we evaluate a prime number is basically we can take a modulo, use the modulo operator to find the remainder, and if there is a remainder, then there is a possibility that it's a prime, but it does not essentially say that it is a prime. So let's look at the definition of a prime number. So I have the Wikipedia page open over here. It says a prime number is a natural number greater than 1 that cannot be formed by multiplying two smaller natural numbers. Let's see what other definitions we have. What is a prime number? Let's look at this one. So it says a prime number is a whole number greater than 1 whose only factors, scroll down to continue. Okay. Whose only factors are 1 and itself. A factor is a whole number that can be divided evenly into another number. So this is the definition of a prime number. A prime number is a whole number greater than 1 whose only factors are 1 and itself. So 1 is not a prime number, and we did a good job by eliminating 0 and 1 from our list. So let's put a comment and the definition of a prime number over here. Now for us to make the comparison with another number, we can probably do another for loop within this for loop. So we can say for j in range, and we want to iterate between the numbers from 2 and the I, whatever number is in I. So let's say the I at this point is in the 10th iteration, or I is equal to 10. So the range would be essentially 2 to I in this case. So what we're saying is for j in range between 2 and 10 if I equals to 10. And now we can compare the modulo. We can take out the modulo for I modulo j and we can see if there's a remainder. So remainder is equal to I modulo j, and we can append all these remainders and put them into a list. So we can say remainders dot append remainder. So now for any given number that we are iterating over, we will get the a list of remainders. And so now is the tricky part, and instead of putting the remainder over here, let me put it up in the top so we can see what is happening with the remainders, and let's output the remainders. So we get a list of remainders, all of them, but that's not the right way to do it. So we can say remainders list equals to this, and we can put the remainders over here, and we will now append remainders list dot append remainders, and then let's output the remainders list, and let's see what's happening in here. So what it's going to do is it's going to go into each number, get the remainders, and then append them to the remainders list. It seems that it's taking a while. Let's just give it a moment. And there you go. We got the remainders now. So if we look at it, we have for the number 2, there are no remainders. For the number 3, the remainder is 1. For the number 4, the remainder is 0 and 1. And why is it 0 and 1? Because when we use the modulo operator on 4 modulo 2, then the remainder is 0. When we do 4 modulo 3, the remainder is 1. And when we take it for 5, the modulo of 5 modulo 2 would be 1, because 5 by 2 is basically 2.5. So there are two 2's in a 5 and then a 1, so the remainder is 1. And then 5 modulo 3 would be 2, 5 modulo 4 would be 1. So we are seeing a pattern over here that is essentially any number, and we know the first few prime numbers over here. So let's say 2 does not have any remainders at all, right? And so it is a prime. It doesn't have any remainders at all. And if the remainders are not 0, so essentially if there is no numbers in the list, or if there is a 0 in the list, or sorry, if there's no numbers in the list or there is no zeros in the list, then those numbers are essentially prime numbers. So in this case it's 2, 3, 4 is not a prime, 5 is a prime, 6 is not a prime, 7 is a prime, 8 is not a prime, 9 is not a prime, 10 is not a prime, 11 is a prime, 12 is not a prime, 13 is a prime, and so on and so forth. So we can probably also print it out in another way, wherein we can say for I and remainders in zip of range 2 to 1001 and remainders list, print I, and then let's put a colon and then remainders. And when we run that, we'll get a nice list of numbers with the solution, the list of remainders. So 2 over here is a prime, 3 is a prime, 4 is not a prime, and so on and so forth. So how do we now eliminate the non-primes and just leave the primes. So we can probably, within this for loop, we can write a if statement, if 0 not in remainder, and that would be sufficient for also capturing this 2, because 0 is not in this list either. So it will capture 2 as well, and 3 and 5. It'll skip 4. So if 0 not in remainders, then let's do primes dot append I, and let's delete or let's just comment this out for now, and I'll not have a remainders list, rather I'll have a primes list. Alright, and let's output the list of primes, and there we go. We now have all the prime numbers between 0 and 1000, all the way up to 997. That's the last prime in the list. Okay, now that we have this, we can probably delete these lines of code. We don't need those anymore, and this one. Alright, now the answer, the way they want us to show it is 2 and 3 and 4 and 2 and 3 and 5 and 7. So they want us to concatenate it. So we can just probably put in an ampersand and use the join function and then join the primes. Right? So it will not run because we will get a type error, and let's go through it. So we did get a type error. The reason being, it expected a string and it found an int. So we are trying to concatenate a string, and the ampersand is a string, with a integer, with an integer. The numbers in this list are all integers. So we can probably just cast it as a string over here, but not in here. We can actually do it right here. When we are creating the list, now we are essentially creating a list of primes in the form of a string. Let's look at that list. So now you see we have a list of primes in the form of a string instead of integers. And now when we run this particular join, we get the answer as 2 and 3 and 5 and 7 and so on and so forth. So that's the solution that I was able to come up with using Python. And there are probably other ways of approaching this problem, and if you have any other methods, please do feel free to comment about it. Thank you.